What we're going to be talking about today is how the unit circle relates to our graphs of sine and cosine, or sine and cosine in general. Okay. So what you're going to find on the next page is going to be a picture of our unit circle. And you're going to take point P and you're going to drag it around that unit circle. And I want you to pay attention to the coordinates of point P and how they relate to sine and cosine. Okay? So once you do that, once you take a little time and you pull this point P around, notice the angle measure, I want you to make a conjecture about how the coordinates of point P are related to what sine and cosine are equal to. Okay? So I want you to take a minute and play with that. Okay, so what's the connection between point P, the coordinates, and the values of sine and cosine? Good. Cosine and sine are my x value and my y value, right? Cosine is what? X, and sine is y. Good. Any problems with that? So we had already talked about that, right? So we know we have some nice values. We know at 180 degrees we're at -1, 0. At 90 degrees, what are we at? Not everybody at once. 90 degrees, what's my point? 0, 1. How about 270? Without looking at it, what is it? 0, -1. Okay. So that's just your connection. So your conjecture should be that sine is going to be our y coordinates and cosine is going to be our x coordinate. Got it? Okay. So what's important about this is the distance along the x coordinate, or the x-axis, is cosine. When I say distance along, I'm talking about this distance here. Okay? That's what our sine or cosine equals at any given value. Okay? Our height on the y-axis is going to be our sine. So from here to here is our sine. Okay? Tangent is y divided by x. So we talked about that a little bit before. So what I want you to do is I want you to go ahead and press play or start the animation on your calculator and just see how sine and cosine change. So I want you first to focus on cosine, how that distance along the x-axis is reacting as we travel around the unit circle. Once you've kind of looked at that, I want you to take a minute and look at sine. How is the height along the y changing as I go around this unit circle? Okay, so go ahead and take a minute just to view that. All right, so let's talk about cosine. Sound like a plan? I'm going to start my pointer. You guys just look up here. I'm going to start my pointer at a rotation of 0, right? What's the length along this x-axis? It's 1, right? Because we know the unit circle has a radius of 1. So as my rotation gets larger, as I start my rotation, is x getting bigger or smaller? Smaller, right? This point is getting closer and closer to the x-axis. It's getting smaller, and it's approaching what? 0. And then it gets, well, distance is getting bigger, and it's getting closer to -1. And then it gets smaller, and it approaches distance of 0. And then it gets bigger again, and it's approaching what again? 1. Okay, so now let's talk about sine. So sine is the height on the y-axis, right? Right now it's 0. What's happening to it? Is it getting bigger or smaller? This height. Bigger. And what's it approaching? It's approaching 1, right? It's getting big, and it's approaching 1. Now it's getting smaller, and it's approaching 0. So there it is at 180 degrees, it's 0. And now as we approach 270 degrees, it's getting bigger, and it's going to what? Careful. -1. Very good. And as I approach 360 degrees, it's getting smaller, and it's approaching 0. Okay, so all of this is actually really important because what this allows us to do is it allows us to graph our sine and cosine functions. Okay, so on the next page, what we're going to do is we're going to see how the distance along the x-axis for cosine actually graphs this out for us. Okay, so I know yours starts in a different position than mine. I apologize. So if you want to just watch it up here, if you want to do it on your own, that's cool either way. Okay, so I'm going to press play. Right now, my rotation, my angle of rotation is 0. Theta equals 0. Okay, so as it increases, and it's not plotting for me. Is yours plotting for you? Okay. Okay, so as this goes around the unit circle, so again, we're talking about x, so the distance along the x. Notice it's getting smaller and getting closer to 0. Here's 0. And then it's getting bigger and it's getting closer to 1. Okay? So where does our function start? We're starting here. Where is our function starting? 0 degrees. 1. When does it hit 0? How many degrees is that? 90 degrees. So at 0 degrees, it's 1. At 90 degrees, it's 0. What's this? -1. When? At 180. Very good. When is it 0 again? 270, and then back to 1 at 360. Okay, so it goes 1, 0, -1, 0, 1. 1, 0, -1, 0, 1 as it goes around that unit circle. Okay, so this is our distance from the origin along the x-axis, and it graphs us this curve. Now, does it stop here? In one rotation, does it end? No, it continues to go on and on and on forever, and that's called, what is the word, Brittany? Cyclic, right? It's cyclic. What are things that are cyclic? Seasons, yeah, the phases of the moon. Okay, so these trig functions are cyclic functions, and they oscillate between two values. Do you guys know what oscillate means? No? Okay, oscillate means it bounces between two fixed values. So what two fixed values does our cosine curve bounce between? What's its max and its min? 1 and -1. So it's going to oscillate between 1 and -1 when we haven't changed anything. It's just a basic trig function. Okay, so now let's talk about sine. Go on to the next page. Well, page after, that's your data capture. Okay, so we're not starting at 0. I'm starting at 197. I apologize. I need to adjust that. So go ahead and press play. And again, when we're talking about sine, we're not talking about length on the x-axis. We're talking about height on the y. Okay, so this piece here. So go ahead and watch that rotate around, and then we'll talk about what it means. Okay, so where's our trig function begin? Well, right here. Where's our trig function begin? At 0 degrees, what's the height along the y-axis? 0, right? As it approaches 90 degrees, what's happening to the height on the y-axis? It's getting bigger, and it's going to be what? 1. So 1 at 90, right? 0 to 1, 1 at 90. Then where's it going? 180, and it becomes 0. And then at 270, it's -1, and then it ends at 0 again. Okay? So this is a little bit different. We go 0, 1, 0, -1, 0. Same value, still oscillates between 1 and -1, but it's kind of starting in a different position, right? Notice this kind of looks like a sideways S, and this one kind of looks like a sideways C. All sine and cosine are translations of one another. If I were to shift this over so that we started here, right, it would look like a sine curve. So it's just a translation of one to the other. Okay. So you have your paper plates out? You should. Say yes. Yes, okay. So I want you to take your paper plates, and we should be able to very quickly determine the values for all of these. Now, we should be able to do that because you wrote down points at every single angle rotation, correct? Okay. Cosine is what coordinate? X. Sine is y. So if I want sine of 30 degrees, I'm going to go back and I'm going to look at 30 degrees. And what did we say our point was? So what's cosine at 30? Radical 3 over 2. What's sine at 30? 1/2. Okay, so you're going to go around, use your paper plate, and find all of these values. Okay, so go ahead and take a few minutes to find all of those values. Okay, sine at 30, what was it? 1/2, good. Sine of 240. Good. And notice, since 240 is in the third quadrant, sine is negative, right? Third quadrant, sine is negative. Cosine at 90, 0. Cosine at 180, -1, excellent. Sine at 90, 1, good. Sine at 135, radical 2 over 2. 135 is in what quadrant? Second quadrant. Sine positive or negative in the second quadrant? All students take calculus positive. Good. Okay, cosine of 150. Good. 150 is in the second quadrant. Is sine or cosine positive or negative in the second? Negative. That's where we get that negative from, right? Cosine of 0? 1. Any problems finding those values? Awesome. Okay, next page, guys. All right, so terminal ray of an angle, alpha, drawn in standard position, passes through the point -0.6 and 0.8. Which of the following gives the value of sine of alpha? This should be like 30 seconds. What's the answer? 0.8. Choice 2. Any problems? It's your y coordinate. That's your sine, right? All right, so we already talked about this. All students take calculus and what the A means, the S, the T, and the C, right? We spent quite a bit of time on that. So we know that in the first quadrant, what's positive? Everything. Second quadrant? Sine. So that means what's negative? Cosine and tangent. Good. Third quadrant, what's positive? Tangent. What's negative? Sine and cosine. Excellent. And fourth quadrant, what's positive? And what's negative? Sine and tangent. Great. You understand the ASTC? Good? All right, next page. 11 pi over 6. Okay, since we know that every point on the unit circle has to satisfy x squared plus y squared equals 1, it allows us to create what's called the Pythagorean identity. The reason every point on there has to satisfy x squared plus y squared equals 1, because that's the equation of the unit circle. It's centered at the origin, and it has a radius of 1, okay? What I mean by every point must satisfy it, it means every point that we have determined on that paper plate, if I plug in the x and the y, and I square them and add them together, it has a sum of what? 1, okay? So think about at 45 degrees, we have the point square root of 2 over 2, square root of 2 over 2, right? So that means if I take square root of 2 over 2, square root of 2 over 2, and I plug it into this equation here, it's going to equal 1, we hope. So square root of 2 over 2 squared is 2/4, plus square root of 2 over 2 squared is 2/4. 2/4 plus 2/4 is 4/4, which is 1. Okay, so that's how you prove that those points are on the circle. All right, so we also have this thing called the Pythagorean identity. You're going to learn a whole bunch of identities. This is by far the most important one, and the only one that isn't given to you on your reference sheet. Okay, so it has to be memorized. So you're going to see it written 2 ways. Less likely to see it written this way, most likely to see it written this way. So please write that down, put it in your notebook, star it, highlight it, box it, memorize it. Cosine squared theta plus sine squared theta equals 1, which should make sense, because when we're talking about coordinate points, cosine is what? X, and sine is y. So it fits right into that nice little equation of the unit circle. Okay? Very, very, very important. Okay. All right, so here's where we get into the important stuff. These are the types of problems that we're going to be dealing with, okay? All right, so an angle alpha has a terminal ray that falls in the second quadrant. Okay, so that means I have an angle that's in the second quadrant. It's going to be over here, okay? Second quadrant. So that's your first step. You're going to draw your little rotation diagram. You don't know where in the second quadrant, but you know it's in the second quadrant. Everybody should be putting this into your notebook. Stop staring at me like that. Okay? It's known that sine of alpha is 3/5. We want to know what cosine of alpha is. So here's our second step. We're going to build a triangle. Okay? This first step here helps us to determine where things are positive and negative. What do we know about that second quadrant? What's positive in the second quadrant? Sine is positive here, which means cosine is going to be what? Negative. Okay, second step, build the triangle. So you draw any right triangle. You take any angle in it other than the 90-degree angle, and you label it, in our case, alpha. And we draw in our ratio. Okay? We know sine of alpha is 3/5. Sine is what ratio? SOHCAHTOA. What's sine? Opposite over hypotenuse. Good. So from alpha, opposite is 3, and hypotenuse is 5. What do you know about this triangle? You should automatically be able to tell me what that third side is. 4, common Pythagorean triple, right? So we're going to label that 4. Third step, we want to know what cosine of alpha is. Well, do we know the ratio for cosine? What is it? Adjacent over hypotenuse. Good. What's adjacent? Yep. So what is it? 4. And what's the hypotenuse? 5. Now, really important step here. Don't forget, check for the sine. What quadrant is this angle in? Second quadrant. What do I know about cosine in the second quadrant? It's negative. So cosine of alpha is negative 4/5. So you always have to go back and check to see if we're positive or negative. Okay? Always, always, always. We did not get as far as we should have. So your homework is going to be pages 9 to 11. 9 to 11. And for those of you that didn't bother to do your homework last night, now it's 8 to 11. Got it? Okay. We'll finish this tomorrow, Monday.